Welcome everyone to our webinar about automating platform monitoring and lowering the data TCO. And in this session, please feel free to use the comment section and if you have any questions. And let's begin. As you know, modern data platforms are the engines driving our businesses and AI initiatives. But manual firefighting and broken pipelines continue to drain resources and erode trust in our data. Today, we are going to show you how an enterprise data operations platform acts as a unified control plane over your entire complex ecosystem. We will demonstrate how continuous context intelligence allows you to detect issues early, understand downstream impact, act through automated resolution, and govern continuously. This closed-loop operating model turns operational intelligence into trusted data, lower your cost, and measure your business value. And joining me today is Zeynep, our senior data and AI specialist, and she will be driving our demonstration today natively within 𝗷𝘂𝘀𝘁𝗄 control plane. Zeynep, over you to please.
Thanks, Ismail. Now, before we look at an operational issue, let me quickly introduce the environment we will be using. And in this environment, we are working across several technologies that are commonly found in modern data platforms. We have PostgreSQL as our source system, dbt handling data transformations, and Power BI delivering business-facing reports and dashboards. In this example, rather than just cataloging data, 𝗷𝘂𝘀𝘀𝗁 has automatically built an enterprise data lineage, so we don't treat these systems as isolated platforms. The solution stitches together the full end-to-end lineage and the business context, allowing us to understand exactly how data moves from source systems through transformation processes and ultimately into business reports and dashboards.
Yes, I think this context intelligence is critical. When a process fails, the real challenge actually is not just knowing a pipeline broke, right? It is understanding the business context and what downstream assets depend on it and what the true business impact will be.
Exactly. That's where operational observability begins.
Okay, so now that we have the context and we understood how the systems are connected, now let's look at the detect phase of our operating model. Could you show what happens when an issue occurs within the platform?
Sure. Now, let's simulate a real operational scenario. Here, this is our dbt production analytics pipeline, and here I'm triggering this transformation job that processes the data within the platform. And as expected, this run has failed.
Right. And to be fair, failures like this aren't unusual, right? The pipelines fail, dependencies change, and source systems evolve. And the important thing is how quickly the control plane can automatically detect these operational anomalies, right?
Exactly. Instead of waiting for a ticket, 𝗷𝘂𝘀𝘀𝗁 acts as an active metadata fabric, continuously harvesting operational signals from dbt and bringing them directly into the environment where users already govern their data. For example, if we start with the source asset, orders. Now let me expand this context, and we can immediately see the operational telemetry that has been captured directly from dbt. And alongside the business and technical context here, we now have access to operational indicators such as the freshness status, freshness threshold, last load date, run ID, and a direct link back to the DBT execution itself. So this gives users an immediate view of the health and the timeliness of the underlying data without needing to switch between multiple operational tools.
So at this source level, we can instantly detect whether data is arriving as expected, but what about the transformation execution itself?
Exactly. So that's where we move from the data freshness into deep execution visibility. So here, if we open this DBT model, we can see a much richer set of operational details associated with the transformation process. Now here we can see whether the latest execution was successful, when it started and finished, and exact message returned by the execution. And for operational teams, this provides immediate visibility into what happened during the run. And we can even review the compiled code that was executed, providing complete transparency into the transformation logic that was run. So rather than just cataloging this data, Alex brings together business context, technical logic, and operational telemetry into a single experience. This allows users to move from passive discovery to active operational troubleshooting without leaving the platform.
So great, now that the control plane has detected the failure and we have the information, and we must move into the understand phase, because visibility without context creates noise, right? So the next question becomes, what impact does this failure actually have on the rest of the enterprise ecosystem?
Now, identifying this root cause is only the first step. When a critical transformation fails, organizations need to understand the broader impact across their data ecosystem. So, using the data lineage established earlier, Alex automatically maps the blast radius across all downstream dependencies connected to the failed DBT job. And this includes datasets, reports, dashboards, and all business processes that rely on the affected transformation. So this transforms a technical event into a business-aware intelligence, identifying affected downstreams across the ecosystem and flagging them for assessment. And then Alex performs an AI-powered impact analysis because it leverages context intelligence. It evaluates the operational issue, not just technically, but in the context of its downstream dependencies, business relationships, and the governance policies. The assessment results are written directly back to the impacted assets, providing immediate impact summaries, contextual explanations, and clear business impact insights.
So great. We have identified the issue and assessed its impact across the data system. But the intelligence without action creates no value, right? We now move into the act phase. How does EDOP convert this intelligence into operational action to guide the engineering team's resolution?
To operationalize this intelligence, Alex automatically initiates a remediation workflow and routes the issue to the appropriate team. So the assigned engineer receives a notification and can immediately begin investigating the incident. Here we can see the impacted model along with the assessment generated during the previous step. The assessment has been written directly back to the asset itself, giving engineers immediate visibility into the issue. We can see the asset, the business impact summary, and all recommended operational playbooks, just all in one place. And Because most tools stop at visibility, 𝗍𝘂 continues into execution. Alex has already orchestrated the automated creation of 𝗀𝘀𝘁𝗁 and linked it back to the asset. So this creates a seamless closed-loop operation connecting the incident, the impact assessment, and the remediation process.
And that's amazing. So we have detected the failure, understood root cause, and also acted by initiating the automated remediation process. Now, let's understand the governance phase. Governance should operate continuously, right? Not periodically. And can we see how this issue flows through the rest of the data ecosystem and how we proactively govern the downstream consumer experience?
Absolutely. Here we are looking at the end-to-end view within the data lineage service, starting from the failed model, and the failure is clearly identified, and because the impact was propagated earlier, we can immediately see which downstream assets are affected. We can already see downstream models and the tables that depends on this failed process and are now at risk of receiving incomplete or outdated data. And as we continue following this lineage, we move beyond the data platform and into the reporting layer. This is where technical incidents begin to create a business impact, and the affected data sets feed operational reports and executive dashboards used for decision-making across the organization. Because the 𝗍𝘂 control plane continuously connects operational signals with context intelligence, impacted reports are automatically flagged, and teams don't need to manually investigate the dependencies or determine which consumers might be affected. The impact is immediately visible here.
That's powerful. So a failed transformation can quickly become a business problem if it reaches critical reports and dashboards. And being able to continuously enforce accountability and identify affected consumers this early actually helps teams contain the impact before it spreads further across the organization, right?
Exactly. So Alex helps organizations understand the full blast radius of an operational issue, from the failed process all the way to the business assets that depend on it. So teams can prioritize their remediate efforts, protect critical reporting assets, and maintain continuous operational resilience before service levels are affected.
So thank you, Zeynep. So the complex data ecosystem generates the constant stream of operational signals, right? And the challenge is really a lack of information. Actually, the challenge is turning that information into an operation control. So in today's example, we demonstrated a continuous closed-loop operating model. We started with a failed transformation and detected the anomaly, understood its effects across downstream assets using context intelligence, and acted through automated remediation workflows, and governed the business outcomes by proactively alerting customers. So by leveraging an enterprise data operations platform that Alex Solution provides, we are enabling teams to prioritize effectively, lowering the data TCO, and deliver reliable, trusted data for analytics and AI. And thank you for joining us today. Please feel free to leave your questions in the comment section and we will get back to you.